C. Find the steady speed at which B can maintain when its engine is working at the same rate at P. Well, working at the same rate, what does that mean? Well, the rate of work is power. So in other words, what speed can B achieve working at the same power? Okay. Well, first of all, we've got to work out what that power is. But let's say you have a certain power and you apply it to a vehicle. The vehicle will accelerate. It will increase in speed. It will get to a certain point where it can't go any faster, and that's what we're trying to find. And if you keep that power, it will accelerate, but eventually it will be steady. It will be at its maximum speed. Okay, so that's quite a difficult thing to understand, really. Okay, so we're trying to find the steady speed which B can maintain. In other words, the highest speed it can get to. Okay, that's what we're looking for. The first thing we're going to do is calculate this power. Okay, there's our power equation. We talked about it earlier, why power is FV. Okay, so we want to know what this power is, the power at P. We know from the last question that the driving force was 3200. So therefore, this power is going to be 3200 times the velocity at P, which was 25. So this power comes to 80,000 watts. So our question is, with 80,000 watts, what speed can you get to? Okay, so you apply 80,000 watts, the vehicle will increase in speed, and then it will get to its maximum speed. What is this speed? Okay, I've drawn a diagram here. I haven't put all the forces in. Okay, it's going in this direction. Okay, and I put in the resistive force of 1200, which is constant. Now, if you apply a force greater than 1200, it will accelerate because it's not in equilibrium. Okay, so there comes a point when it's going at constant velocity when the driving force will be equal to 1200. If we go back to our power equation, power is FV. Now if we make F a subject, F is power over V. So F is the driving force. Okay, now the driving force comes from the power and the velocity. So the higher the power, the higher the driving force. But the higher the velocity, the lower the driving force. So as you can see, as the car gets faster, the driving force decreases. Okay, so if I put that on here, so there's our driving force. Okay, and our driving force is going to be P, which is power, over V. So take a look at that for a second, make sure you understand it. Okay, so while this is greater than 1200, the car is accelerating, and as it accelerates, V gets bigger, so this force gets smaller. And then when this decreases to 1200, it just stays at a steady speed. So in other words, it's when 1200 equals 80,000 over V. So that's what we've got to calculate for V. Okay, so our steady speed or our maximum speed is when 1200 equals 80,000 over V. So we just need to calculate for V. So V is going to be 80,000 over 1200, which calculates to 66.7. 66.7 meters per second.